there. Because I was like, if a Danish person comes up and talks to me, I'm switching to English. Because I can't handle when I'm speaking to them in Swedish and they're like, läste du det? And they have the audacity to say like they don't understand me. Hi. Helt dränkt.
Tror inte vi får sätta oss.
Ja, tack så jättemycket. De skulle inte använda den här.
Vi är bara på max.
Platsvärden till kameran ligger där inne. Jag tänkte vi behöver ta bilder.
Sant.
Vilken Instagram är det här?
Facebook, YouTuben.
YouTube?
Ja.
Kan du skicka länken i Slack?
Den ligger i Slack LFS25 January.
Skit.
Smart av dig.
Ja.
Smart.
What is Aero Team? The history goes back to the 80s, when the industry thought that newly graduate students were lacking hands-on experience on how to apply their theoretical knowledge. So to solve the issue, someone came up with the idea to do a competition where students got to collaborate and apply the different skills of the year. So that's a short story about how former students was born. In former student, you can compete in 3 different classes: combustion vehicle, driverless vehicle, and electric vehicle. So the competitions take place all around the world, but we mainly compete in Europe. The competition tests both the theoretical knowledge from the team, but also the performance from the car. So about Lund Formula Student. It was founded in 2006 at Lund University, and since then we have been working hard with designing, manufacturing, and competing with cars. And of course, for my students, it's a lot of fun, and you get to transfer. The structure for LFS25 looks like this. We have 2 leaders, 2 administration sub-teams, 1 research and development team, and 1 alumni group. And of course, we have some technical sub-teams. So total, we have 6 technical sub-teams, each consisting of some subsystem, that I will spare you them, and all the managers will tell you about them later. And And in total, we have 99 voluntary students this year, and about 18 years of experience. So the timelines for LFS25 so far have looked like this. In April, all the leader and mentors were recruited, and work began right away with interviews, preparing for some project, and planning for the autumn. In June, all the members were recruited, and the whole team started preparing for the design phase. In September, the team met for the very first time. We had a kickoff and started designing right away. And now we are finally in December, and we are reaching the end of the design phase. And now our focus has switched towards prospecting to be able to qualify for the competition, and also planning for the manufacturing phase. So before I hand over to our business and marketing manager, we're going to look up the best 5 years so far really quick. We've had over 1,000 cups of coffee so far. The most productive week was week 47 with 1,600 combined hours of work. We have said the word optimized in the wrong context 582 times. The critical total labor cost of the design is €250,000 per week. And time step was not enough, but it was worth it. And now it's time for our business and marketing manager, Tor. Welcome on.
Yes, my name is Tor, and I'm the business and marketing manager for LFS25. Business and marketing is a fun sub-team because we don't build a car, we do everything alone. So we plan events, we handle sponsors, and we do PR. So to help me unify these personalities that do a lot of different things, I have these people behind me, and they're very good. They're divided into corporate relations and finance, event, public relations, and they're all very good at their job, and I like them very much. So the first part of business and marketing is of course corporate relations and finance. This year we have managed to do a drinks sponsorship from Carlsberg, which has greatly improved the team morale and gained a lot of positive vibes on the campus. We have also devised a framework to gain more technical expertise from the sponsors that we have, asking them questions, stuff like that. Because of course we are just students, we don't have the experience that you, the audience, the sponsors have, which is why we want to ask you more questions about the problems we have and how to solve them in the future. We also try to widen our sphere of influence, reach, and interest. A lot of companies we talk to are very technical in their business, but it doesn't hurt to ask you. Is 100% of the chances you don't take, which is why we just send emails to a lot of companies now, and we have seen success with it. We also have plenty of business opportunities from the past months. So if you worry about what we will do when the car is built, you don't have to, because Dear Sirs Automotive want to do business with us. We have a luxury replica seller from China. We have Hello Sir, myself, Rambert. He's very interested in aerospace engineering, so maybe he wants to do something with us. We have very good price and quality for basalt fabric. We don't use basalt fabric, we never have, but if we were to, it will be better for you to know different price. Public relations, it's interesting because when the technical part of the team does a mistake, they have very many places for people to notice it. A team member, as manager, alumni. But when public relations does a mistake, which happens because everyone does mistakes, it's broadcasted to the entire world immediately. Which is why there's much high pressure on the public relations team. That's why we've implemented a 3S framework, where they have to be approved by PR, me as a manager, and Nova as a product leader, which hopefully, and I think has, made us more consistent in our social media, and better. They have conducted manager interviews, posters, much more, and we have one of the most successful recruitments ever, with over 50 applicants this fall. We also gained over 3,000 followers on Instagram, which shows increased support for us and the team we have have. So event, the last part of the business marketing sub-team, they bring the whole team together. We held go-karts, we held a real evening, and we held a pub, which is very valuable to people that work so hard on a car, because it gets them a chance to forget about deadlines, forget about manufacturing, and just relax, have a beer with the team, and chill. They've also done this beautiful event that you're here on today, so a big round of applause for event, please. Oh, and they did a show run as well, of course. Very good success. We did better with 2 cars this year, so next year we'll try to aim for 3. But yeah, that's all for me and the business marketing sub-team, so welcome up Mattis and the technical leader.
Thank you, and hello everybody. I'm Mattis, I'm the technical leader of LFS25, and I'm going to tell you about the overall vehicle concept of this year. So first off, brief history of the LFS electric era. It all started in 2021 with LFS21. It was a car on May 1st, the first monocoque in many years for LFS, as well as the first fully electric car. It was pretty heavy and bulky, and that's why it was nicknamed Tunnan. The next car, Tunnan 2. Slimmer, faster, lighter, but still many areas for improvement. LFS23, nicknamed Draken, was a big step forward in many regards. It achieved as much as a top 3 finish at the endurance event in FSM. Now last year, Viggen, LFS24. It was the most powerful EV car to date, and it achieved the fastest acceleration time in LFS history, thanks to Gilles right foot. It was also the first time LFS finished on the podium in the business plan presentation event. Now for this year, LFS25. Of course, we aim to build on the success of the previous years, with an increased emphasis on simulation and data-driven design. We also want to get more testing in before the first competition, and ensure LFS is competitive for many years to come. As Nora said, we're nearing the end of the design process, but it all started with evaluation of last year's car. So new for this year is the LFS Analytics website, which gives all of the members access to the data we recorded during our testing. Because we built a virtual model of the car to test our different parameters, and that's why we had more testing after the season was finished. Like this test for the upcoming FS Lapland event, where we took a leaf out of Borgvarner's book and conducted a snow test at Lapland. So next up in the design process is setting the goals for the team. Starting off with the competition goals for LFS25, we want to achieve a top 10 finish in 2 dynamic events, as well as a top 7 overall and in the electric class and a top 5 in the driverless class. When we build a car, there are many different degrees of freedom. We need to boil them down to some overall performance parameters, some of which you can see here. The weight of 210 kilograms and the peak power of 80 kilowatts. And these goals were set through event simulations, and really it's the heroes of the vehicle dynamics sub-team that we have to thank. It's no good setting goals if you don't know that you will achieve them. So for this year, we've introduced a centralized tracking system with a huge parts list, infamously known as the master parts list, where we have every single part of the car in a big Excel sheet. This helps us find potential problems early on, as well as integrate the manufacturing phase and the design phase. It also helps the whole team strive towards a common goal. Yeah, I might have mentioned it once or twice. With the overall concept of LFS25, we aim to get as close as possible to the performance limit of the real design concept. We want to realize that design potential by getting a lot of testing kilometers in. We also have a strong focus on integrating the DV systems. Secretly codenamed Gripen, but don't tell anyone. Now this is where LFS25 will hopefully stack up against against the rest of the LFS electric era. For LFS 26 and beyond, as I said, we want to ensure that LFS is competitive for many years to come, which is why we've appointed 2 R&D managers, Robert and August, for the first time. As you can see, we see that we're getting close to the potential of the rear-wheel drive concept, so we feel like a transition to all-wheel drive is necessary and natural. Not only is this going to require a lot of the hardware, but also there will be lots of new software development needed. So now, for the design of the car, and the different managers are going to tell you about their technical achievements. First up, Theodore, Monaco manager.
Hello everyone, and thanks for coming. I want to start off by introducing the Monaco team to you all guys. So first of all, a monocoque is a single-piece carbon chassis, and this is, like Matti said, we have done for a couple of years now. We consist of 8 members in total, divided into 3 subsystems, and the purpose of this is to protect the driver from impact, obviously, and it would be very nice without the subsystems to have something to mount their stuff to. So that should be done as well. So, for the design, the first subsystem is monocoque design. Their goal is to design the new chassis with integrating all the design changes. And our major achievements from this year is that we managed to make a slimmer and a lighter monocoque with almost 3 kilos lighter than the previous year. We have also integrated a new aluminum front tube, which will reduce the weight by an additional 800 grams. The nice guys in the monocoque design they conducted this nice study for us as well. And interesting results showed that the more experienced that our members got in SolidWorks also made them love it less. Progressively, it was like 1-to-1 ratio for some reason. It's exactly like this. The next subsystem we have is safety and ergonomics, and the purpose of this team is to make sure the driver is safe and can perform at his or her best. So, achievements here, we managed to make it lighter and smaller impact structure to fit the smaller front of the car. We also put a lot of focus on quantifiable ergonomics, because we could see that there is a ratio between how much the driver suffers while he drives, as well as how quick and compact the car can be. And so basically, if you see this chart here, you can see that in the top right, you have a very, very good car, but it's undrivable. In the far other corner, you can see that it's a really shitty car, but very comfortable to drive. But with this new approach, we ended up in the very, very nice sweet spot over here. So we will be the best from an ergonomics perspective. And someone have also mentioned that you should never try to reinvent the wheel. These guys will tell you otherwise. So we have reinvented the steering wheel for this year. As you can see, very nice piece that will also help the driver to perform better and integrate a lot of the electronics into the steering wheel instead of external. And for the structural sub-team, their purpose is to make sure the car has a structural equivalency to that of a steel frame car, essentially making sure it's structurally sound. So we have also managed in the sub-team to reduce the weight of our inserts by as much as 33%, which is a huge percentage considering compared to other subsystems. And this we also managed, thanks to a new manufacturing method for test panels, to come up with some new layouts that we're going to introduce to this year's car. This will also help with the almost 3 kilo gain or reduction of the mass of the car. Last but not least, we have the FEM analysis. This stands for Finite Element Method. And what this basically is that we want to analyze our composite panels and the car by applying simulations to get a more iterative design process that can help us make the best choices we can for the layout of the car without compromising the stiffness. So we can see how the new and old simulations, we compare them and see that by applying this new layer, we are able to, and other design changes, we are able to lose weight without compromising our stiffness. And overall, the concept in total, this is what you will get. So thanks for us, and I will now hand over to Ville, the chassis dynamics manager.
Hello everyone, I'm Ville and I'm the manager of the Chassis Dynamics subteam. We are the biggest subteam and we have 13 amazing people in 7 different subsystems. So what is the purpose of Chassis Dynamics? Basically, we design and manufacture all of the moving parts of the car. We have a heavy emphasis on simulations and hand calculations. And we are also probably the biggest annoyance to other subteams, since whatever changes we make, they have to adapt to. And what have we accomplished so far? Well, for this year, we've implemented a total of 5 new simulation programs to get a better idea of the car before we build it. We've also repackaged the suspension in order to ease the transition into a multiple motor concept, as Mattis mentioned. We've also completely obliterated our weight target. So we set a target of a 1.6 kilogram reduction, and according to our calculations, we managed a 5.4 kilogram reduction. So for our first subteam, vehicle dynamics, as Mattis mentioned, they decide basically all of the big parameters of the car. And their purpose is, well, they basically handle every aspect concerning performance and handling of the car, as you can see in the GIF. And they also work with getting the tires and the suspension to work together. And finally, they're a subsystem driven by pure data-driven design, using both lap time and motion simulations. So for suspension and uprights, the purpose of this subsystem is to ensure the best possible tire contact with the road at all times. And we managed to reduce the weight by 1.5 kilograms. We've also worked with our manufacturers early in the design phase to get a faster outsourced manufacturing come spring. For the steering and braking, these subsystems are the only way for the driver to control the car. So it's really important for a responsive experience. That's why we focused on a stiffer, less free play and less rotation and movement for the driver. And we've accomplished all this while reducing the weight by 1.2 kilograms, which is the 36% decrease, which is massive. Finally, for our second to last subteam, it is motor and drivetrain. The purpose of this subteam is to transmit the torque from the motor all the way to the wheels. And this year we've increased the efficiency of the subsystem. We've also designed a more robust mounting. And to do this, we've done a bunch of different simulations in many different scenarios that can occur while driving. And that's it for me. Now over to Georg in the powertrain subteam.
Yes, I'm Georg. I'm the manager of the powertrain team. But first, here's the team. We're 9 people, 9 dedicated engineers divided into 6 sub-teams. Our mission is to power the motor and cool the motor while driving it. So what is a powertrain? The powertrain is essentially the flow of power from the source to the wheels, or the ground really. But what we in LFS define the powertrain as is everything before the motor in the sense of power. So we have the accumulator, we have the tractor system as we call it, and the cooling system. Now let's follow the power. The source of the power is the battery cells. Each cell has roughly 13,000 milliampere hours at 3.7 nominal voltage, meaning it's roughly equal to 4 iPhones. And we have 144 cells, which is a lot of iPhones. These are then stacked into segments, where each segment houses 18 cells each. And this year we have reduced the weight of the segments by changing materials inside of them from aluminium to FR4. And further, the energy of one segment is roughly 3.1 megajoules, which is roughly equal to digesting 26 Pepsi cans. And to house the segments, we have the accumulator container, which is essentially the battery pack itself. This is the large change for powertrain this year, making it out of composite materials, more specifically aramid fibers, also known as Kevlar. And so far, we have made over 20 test panels this season, some of which are theoretically bulletproof, so we hope to catch no fires here. And further, the energy of the total accumulator is 25 megajoules, which is enough to launch a person above the ozone layer, or roughly 31 kilometers up into space, in ideal conditions. Now, we have a lot of power, and we need to make it safe and control it and distribute it to the car. This is what the accumulator electronics does, having the airs that basically turn on and off the battery pack itself. And the new for this year is reducing the weight of the airs and size of them, and replacing some of the wires with bus bars to ease the packaging within the accumulator itself. Then, to summarize, we basically have a big box with 600 volts, 130 amps, delivering 80 kilowatts, which is a lot. And it's the heaviest part of the car, weighing roughly 55 kilograms, but through these changes we have made it 7 kilograms lighter, which is a lot, but not a lot in the total sense. Third, once it exits the accumulator, it enters the tractor system. The purpose here is basically to transfer the power from the accumulator to the motor. Firstly, entering the high voltage box, as we call it, where all the components that need to interact with the high current flow is positioned. And these are mainly the logging system and the safety system and the high voltage disconnect. Then it enters the inverter, where it's converted from direct current to alternating current for the motor. And the motor we use is an MREX HV228, which has a peak torque of 220 Newton meters, which is then transferred to the wheels by wheelless drivetrain. And we use 80 kilowatts, which is roughly 110 horsepower, meaning that our car has the same power to weight ratio as a Porsche 911 Turbo S, which is a quick car. And then, of course, we have a real world, so we do have losses in the system to heat, so we need to keep it cool when driving, otherwise it will overheat. This is the purpose of the cooling system, and the accumulator we cool just by blowing air over it, while we have a big water cycle for the motor and inverter, which get really hot. And new for this year is that we have added a swirl pot to filter out the air bubbles of the system, while also having a more powerful pump to increase the flow rate. That's it for powertrain. Now we're for Leonid and the driverless team.
Hello everyone. So my name is Leonid. I'm the manager for the driverless team, or DV, as you might have heard earlier in the presentation. That's us. We're the smallest sub-team, and our mission is to make the car drive itself. And some common questions we get is the track known beforehand? And the answer is no, it's not. You have to figure it out on the fly. And secondly, we're not allowed to interfere with the car in any way while it's driving, so there is no PS3 controller, RC stuff at all. So you press the go button and you're just supposed to do this. And we're kind of built a little different from the rest of the team in that we don't really like getting our hands dirty and building stuff. We're more into computers and math and theory and simulations and that kind of stuff. So yeah, we don't really like hardware that much, but I'm going to talk about a solution to that a little bit later. So just quickly, how does this stuff work? We have a little black box in the car that you can see in the bottom corner here. That's our computer. And then at the front of the car, we have the LiDAR sensor, which is this great thing here. We have actually a live demo over there if you want to check out how it works. Just don't touch it because it's really hot. So the first part of the pipeline is you perceive the environment using the LiDAR sensor. That's our only eye into the rest of the world. We see the cones, we classify them just like this, and then we pass these observations down to the SLAM algorithm, which basically just means we build a map of the track, which of course is not known to us beforehand. So it kind of fuses measurements and associates observations with the same cone. It's more visible here. So here's the next step, is path planning. So you see the orange little blobs here, that's each cone, and then each orange line is a single observation of that same cone. And then this green line here is the path that the car is supposed to follow. And then finally we have a motion planning algorithm, which basically computes the throttle and steering commands that the car needs to follow this path. And then below that we have a communications layer to communicate with the car and kind of make sure they're on the same page. And this part has actually not gotten that much love in the past few years, so that has been what we've been focusing on. So our goal is to have them be able to perform a clear and consistent procedure for driving the car autonomously. And I mean, if you finish 2 events on competition, you will be top 5. So that's our goal, and that just shows you how difficult it is. So what we've done so far, I mean, we've been fixing a lot of bugs. It's just a lot of issues in general. We got a new state machine, tested it, driving on the car, making sure it starts and stops correctly. Imagine that's actually pretty difficult. Done as much testing as we could. I mean, we had some setbacks, like our servo broke, you know, typical hardware stuff. And that's just how it is. But speaking of hardware, we're gonna, coming up, we're gonna be working on integrating some new stuff. Gonna talk about it on the next slide. And more importantly, we're going to be killing all the bugs that come our way. And the thing with driverless is, as soon as you kill a bug, 2 new spawn in. So as soon as you do something, fix something, you get 5 more issues. But we're used to that by this point. We're going to be fine. It's going to be awesome. So now the big change for this year, and that is that we actually have 2 awesome mechanical engineers doing our hardware. It's Simon and Dante. Big shout out to them. Really good job, guys. So when I say driverless hardware, what I mean is basically the actuators that interact with the steering and braking to actuate them without interfering with the manual driving experience, as well as all the mountings for our computers and so on. So it's totally rethought layout this year. We've gotten rid of we have like the pneumatic braking system directly mounted to the brake pedal. No more of these stupid steel wire cable stuff, like just never use steel cables ever for driverless stuff. You'll be fine. We have a completely new steering system as well. It's this little new black puck that we put below the monocoque, and then it's going to go straight in the steering shaft. Just overall, super great job. It's not an afterthought anymore as it was before. Really happy about that. So, and of course, since we love math so much, we couldn't resist of actually doing some algorithms. So this is a little prototype of our model predictive controller. You can see it kind of cuts quite a few corners, but I promise no codes were hurt in making this video. Yeah, it's cutting corners because we made it as aggressive as possible to drive as fast as possible without like losing its mind. So, yeah, I think we need to put some more love into it over the winter break. Maybe give it some Christmas presents, and it's gonna be awesome. So yeah, while that finishes up, I'm gonna hand it over to the electronics manager, Lucas. Welcome up to the stage.
Thank you, Leonie. So I'm gonna start by introducing my amazing team. Thank you to these people who I've been working with for the past few months. And yeah, what we do in electronics is design and integrate all the electronics in the car. And our most important priority is, of course, safety. So let's start off with control units. What have we been up to? We have redesigned the indicator light design on the battery management system. The new one has much higher efficiency and hopefully is a lot more reliable than the old one, leading to less stressful competitions. We have redesigned some safety logic, which will result in fewer failure points and also allows for rules compliance, which is good. For the front control unit, we have easily accessible debug interface, which if you ever have done any programming, you will know that print line is very useful, and we haven't had the possibility to use print before. So hopefully that will work. On the power control unit, we have made some changes to accommodate the new driverless hardware. The braking system you saw earlier also required some electronic changes. And on the dashboard control unit, we have done the same thing as on the front control unit. We have the new interface allowing us to use print line. And then we also added a new connector so we can have the buttons and the knobs and stuff on the screen. For safety systems, we have redesigned the tracking system light logic board, which is basically tells us if the machine is active or not. And it's a blinking red light on the car. And if all the electronics work perfectly, all you will ever see of us are blinking lights. Yeah, and it has a more compact design, as I mentioned earlier, in combination with the BMS changes. We have fewer failure points. It will also fix some minor design oversights. And then the brake sensor possibility device, it was also designed by LFS25, but never manufactured, and hopefully we will use that one this year. And it should be less susceptible to intermittent errors. For the wire harness, it connects everything in the car. It's all the wires and stuff going to the sensors and the different control units. This year we'll use ferrite beads on the communication bus in the car, also known as the COM, the protocol. It has a measurable improvement on the high frequency noise which we see on the bus. And we'll have a new design workflow utilizing one software a bit more hopefully. And shielded sensor wires, which will also help reduce the noise. Sensors and software have been working hard for the past few months. We have implemented regenerative braking, which is basically wasting less of the car's energy whilst braking, and we recoup some of that through the motor and the inverter back into the accumulator. And in the recent test we did, we managed to gain 10 amps of current, which in power terms is equivalent to boiling a cup of coffee in 14 seconds, which is pretty impressive. Then they have worked a lot with driverless testing, of course, as you saw on the earlier slides. A lot of their code interact with our hardware and needs a lot to function, and it's very good. And then the driver display, we have a new design this year, which will hopefully fit the driver's requirements a bit more, so that they will actually look at it, something that the drivers haven't had much time or need to do previously. Yes, and now over to our aerodynamics manager, Leo.
Yes, hello. My name is Viggo, and I'm the Aero manager. So, Aero, we consist of 6 people and 3 different subsystems, out of which we have 4 aero designers, a guy on CFD heat transfer, and 1 guy on CFD. So, what do? We provide a greater surface area for all our beautiful sponsors, and they of course make the car look very cool. So, what have we done this year? We have simulated a brick, we have played Blocky Pin, and we have done some real-world testing to get a better understanding of how our simulations actually play out in reality. And we have worked on checking the deflection on our wings. So, the aero package, or the next year's aero package. It is quite difficult to show all the new parts without really spoiling the reveal.
So let's talk about the numbers instead. We have a increase of downforce of 25%, so that means we have a CLA of 5.7. And all of that with a very, very small drag penalty. So this means that our overall aero efficiency is up by 22%. And now you might ask, like, CLA, what does that mean? So now we're going to talk about the most important performance metric when it comes to aerodynamics. And that is the velocity at which you can drive the car upside down. And that is at 100 kph. And with that said, that's pretty theoretical, and I wouldn't really like to try myself. So if we remove the driver and let the driver do the thing, we're going to be able to do that at 87 kilometers an hour. I think it's time for the big reveal, but before that, I'm going to show you a small animation of what the car basically does to the air when it travels through it. So yeah, what do we say? Isn't it time for the reveal video? Yeah. This one working?
Well, thank you very much for coming, everyone. And now, please feel free to stick around and see some of the more pictures of the car. And yeah, enjoy the evening.